This conference will now be recorded.
Hey, thanks everyone for joining, and my name is Adam. So, in this session, we'll try to understand completely about container management. So, when I say container management, we would try to understand how do we basically create a container, and then how do we start, stop, or restart it, and in the same way, what are the different methods using which we can attach a container or detach a container. And typically when we are trying to run a container in a detached mode, how is that you will be able to run the commands inside it, see the logs from it, and we'll also be able to see a couple of other commands which will give the statistics about the container. Okay. So that's what we're going to understand in a way, which is what we call it as container management. Now, like I was saying in the last class, a container or Docker can be basically installed on a Windows, a Linux, or a Mac. Now, in that, for the easier purpose of the class, I'll be taking up a Ubuntu machine based out of AWS. Okay. Now, again, it's just my preference, but depending on your need, you can take up any OS and you can install Docker, which will be easy. Okay. So what I'm going to do for this practice is I'm going to quickly take up a AWS machine based out of Ubuntu, and we will install Docker, and then we'll start our work. Now, before we proceed, just to have a quick recap on what we were seeing in the last session is that in a Docker system, when we try to install Docker on a machine, you would be getting a Docker daemon, which is a process which will be running in the background and managing all the actual activity. And we would be using a command line utility called as client, which is what will be communicating to the daemon through all the commands that we give. And we would have a place called registry, and for our practice we will be using Docker Hub, which is the public registry. So depending on our need, we would be choosing a particular image which is available in the registry to be first downloaded and available in our machine, and then using that image we will be creating containers. So that's what the whole session is about, on how do we manage these containers using an image. Okay, so to get started, right? So if you go back here, now typically I have created a machine already, okay? So I'm just trying to connect to my AWS machine. Okay, I've just switched to root. So the first thing I have to do is apt update. Since I'm using Ubuntu, I'll be using a package manager called apt.
Adam, your screen is not changing. So it shows only instances in AWS. There is nothing.
No, it looks like your network is slow. Can you just check again? Is it the same, or for others it's fine?
Able to see. You said apt update.
Yes.
It's fine for us.
If you have a
For me, it's
issue,
fine.
it will happen. I'm going to install Docker now. So the name of the package for Docker on Ubuntu is docker.io. In the meantime, guys, I would request everyone to go on mute so that the recording will be neat. Okay, so what we have done is we have installed Docker. Okay. Now, typically, if you understand, we would have got both the daemon as well as the client. So to cross check whether the daemon is running properly or not, you can use the system service command, or it would be running as a process. So you can also check the process whether the daemon is running. Now, typically, I can go ahead and say ps grep and docker. Okay. If not, you can say docker info. Hmm. So you can see here that there is a process which is running in the background, which is the Docker daemon. Okay. So if a Docker daemon is not running, then you will not be able to access. And this is where now, whenever you install a package in a Linux machine, first you need to install it and then you need to start the service. So the reason why I used Ubuntu is internally the package would also be installed and the same apt install command will start the service. So that is where we don't have to do a two-step work here. So in our case now, in this machine, the Docker daemon is running as well as we have the Docker client. So going forward, we are going to use this command line, which is nothing but the Docker client. Okay, so going forward, whenever I type Docker, what we are actually trying to access is the client. And this client will be communicating to the Docker daemon and it will be helping us to do our activity. Okay, so once the daemon is being started, go ahead and type Docker info. This will typically give you the whole bunch of information on what exactly the Docker daemon is doing and how many containers or images that's been available on your machine. Okay. Now, this is another quick way using which you can cross-check whether the Docker daemon is running or not. Because if the daemon is not running, then you would be getting a clear message where the Docker info will not be able to communicate to the daemon. So it will give you a message saying that is the daemon running or not. So that way, make sure the Docker daemon is running, and then you can start using the client command. Okay. So to get started in working with containers, so now what we are going to do is on this particular machine where we have installed the Docker. So when I say Docker, it's both Docker daemon and client together. So we are going to see how to create containers and manage containers using the Docker client. Now, typically, when you try to say Docker container, now, the way how it is going to be created and accessed will be exactly like a machine or a VM. So what do you do if you want to create a VM using a tool like VMware? Now, typically, you're going to first use an image and create a VM. And after creating the VM, you will be starting the VM. And after you start the VM, you will be going inside the VM whenever you want to do the work. And once there is no work, you're going to come out and depending on your need, you're going to stop your machines, right? In the same way, what we are going to do with a container is we are going to first create a container and then start the container. And based on your need, you will be going inside the container. And whether if you want later when you're not using, you can stop the container or delete the container. Now, for all this, there are different commands or options that we have in the Docker. But one of the popular command which we will be using to do all these things together is Docker run. Okay. Now, typically, when you want to create a new container using Docker, then you will be using this command option called Docker run. So when you execute Docker run, there are a couple of things that it will be doing together. Okay, so let's understand what it does. When you want to create a container, like I said in the previous class or the previous slide, you need to first have an image. So based on the image, you will be creating a container, because a container is like an empty box. It doesn't have any meaning. Only when you put the content of an image into it, it becomes an environment. So that way, before you create a container, you need to know and you need to make sure that the image of your choice is available on your machine. So this is where we do not have to download it separately. When you execute Docker run, the Docker will communicate to the daemon and it will check whether on your machine the image that you have specified is available. Suppose if the image that you want is not available on your machine, then the Docker will go to the registry, whatever that you have specified, and based on the registry, it will download the specific image to your machine. Now, in our practice, we do not have any separate private registry. So by default, if you do not tell any registry also, Docker will be directly connecting to the public registry, which is Docker Hub. Whereas in an organization, you have to specify the registry also. If you do not tell, it will be Docker Hub. So now the very first step which Docker will do is, it will try to check whether your image is available on the machine. If not, it will go to the specific registry. And again, if you do not tell the registry, it will go to the Docker Hub and download the image to your machine. Okay, so this is a one-time activity. Now, once the image is available on your machine, then using that, it will be creating a container. So it will create a process, and in that process, it is going to put a copy of the image into it, so that you will be getting all the content of the image in a read-write fashion inside your container, so that it will be acting as an environment for you. So that is what first is, to create a container. So this is where, just like a VM, once you create a machine, you cannot access, because you need to start it, right? Creating a machine is just that you need to make sure that you have everything that is needed. The same way over here, first container would be created, and after that, it will start the container and it will be assigning a unique ID to the container. So this is again, just like in Git, every commit or a check-in you do, you would be getting a unique checksum or a shawsum value, right? Which is what we call it as commit ID. In the same way, for every container that the Docker creates, it will be giving it a unique ID. So using which we will be able to identify. Okay, so that way, remember, whenever you say Docker run, it will create a new container. Okay, so if you execute Docker run 10 times, then you are going to get 10 new containers. Remember that. Now, how do we reuse the same container? That's what we will be seeing it little later. But in the beginning, when you say Docker run, every time you execute, you will be creating a new container. And for that container, a unique ID will be assigned. Now, once the container is created and started, then what happens is we need to go inside the container, correct? So that is where now there are different ways that we have to tell, but typically to start with, what we will be doing is we will tell to go inside the container in an interactive way. Okay, so that's what we are going to see on what are the options for that. So by telling it to go to the container or attach to the container interactively, you can start working inside the container. Okay, and post this, whatever the command that you want to run inside the first container that you have created, you will be able to run. So this is where there are different options where you can tell what command to run, or the Docker itself can run a default command. So we are going to see all those things as we move forward. Okay, but remember, every time you execute Docker run, these are the steps that it is going to do. So it will download the image from the Docker Hub if it is not available on your machine, create a new container, assign a unique ID, and then start it, and it will attach to that container and then execute whatever the command you have given. Okay, so this is the whole process that will get happened when you execute Docker run. Now, to dig in a little deeper, let's go back to the same command and we'll see what are the options. Okay, so here, when I say Docker run, we saw what are the steps it is going to do. But like we were saying, when you say Docker run, to create a container, you need to typically specify an image that you want to run. Okay, so that is where we will be passing image name as an option. Now, for those who are beginning, you will not be knowing what is the name of the image. So if you go to Docker Hub and search, you will be having plenty of images depending on your choice. The same way, now let's assume if I am working, then if we are going to use a very minimal image for a OS, then those are named after exactly the same OS name. So this is where, if you take an example for this, okay, I would request again everyone to be on mute, please. Okay. Okay, there's a quick question what Raghu has asked. Is there a limit on number of containers that we can create? No, there is no limit on the number of containers created, because if you go back to the previous session that we discussed, it is not that to create a container, some memory will be allocated, but what you run inside the container, so that is what is going to take the resource from your machine. So it's all about what is that you're running on the machine. Instead of that, directly you're trying to run it using a container. So that is where we do not have a limitation on creating the number of container, but what is that you're going to run has a limitation on using the resource on your host machine. So I would suggest you to go back to previous session later and have a look at it. So when you say Docker run, now let's assume I want to take the image of
Adam, I had one other question. So in what cases do we use containers and in what cases do we use VMs? So
okay, so going forward, the requirement is, see, when you need a whole set of machine to work everything, you're going to create a VM. But after you create a VM, for your day-to-day work, if you need different environments, rather than creating multiple VMs, in the same VM, you can use container and use it as a separate environment. For example, now let's assume you go to an organization, and in an organization, what they want to do is there are 10 developers in a project, and for them, they need to give a development box so that they can work, because they cannot directly do all the coding on their laptop. So this is where, as an organization, for doing a development work or a testing work or a deployment, you need one machine. So that would be a VM. Okay, so once that VM is created, all the users will have access so that they can do their day-to-day work. But for them to do the day-to-day work, there will be many applications which they have to install and run. So that is where, if you go back to the previous session, I was telling you that you cannot install all the applications on the same machine because of the dependency of libraries, and things will get corrupted or it will not work. So that is where you are going to use containers, wherein for me, if I am a developer or a QA, if I want 2 copies of my application or 2 different applications running on the same machine, instead of me going ahead with another machine on the same VM that I have, I can create multiple containers for my need, and I can do the test. And whenever I've done with my work, I can go ahead and stop the container or delete the container. So that is where you are
Yeah.
going to use containers whenever you need a environment.
Okay. Thank you.
So here, what I was telling you is, if you want to take an image based on CentOS, which is the very minimal image, then you can say docker run CentOS. Okay, so CentOS is nothing but the name of the image given by CentOS, which has the minimal files of CentOS. The same way, there is an image for Ubuntu. Now, if I say docker run Ubuntu, it will try to take the image of Ubuntu. Now here, the name is straightforward, but depending on your need, there will be different image which will have different name and content. So that is where you need to first know what is the content that you want. Based on that, what is the image available. So for us to practice, we are going to just take a bare minimal image, which will be either out of CentOS or Ubuntu. So this is how you are going to tell the name of the image for the Docker run. So using this, when it creates the container, it will put a copy of this, and as I said, first it will try to download these from the Docker Hub to your machine, and then it will go ahead and create the container. Okay, so this is what about image. But once the container is getting created, if you go back to the slide, I was talking about attaching. So what exactly is attaching here? Now what happens is, if you understand it, the machine in which we are installing Docker is a remote machine, which means I'm not doing it on my laptop or my workstation. So I'm basically using a AWS machine, and in that I have installed Docker. So now, so let it say that this is the machine. Now in this machine, if I say Docker run, what will happen? The container will be created on this machine. So now, if you want to go inside that container in order to do some work, what we have to do is we are going to tell Docker to attach the terminal that we have used to connect to this machine to also to connect to that particular container. Because now if you see this command prompt or terminal, we first attach it to our AWS machine. So that is where I'm able to run all the command, right? Now, when you execute docker run, we can also tell the Docker to attach this terminal or this screen to the container that we have created now. So that way, what will happen? After you enter the docker run command, you will be typically inside the container. Okay, so that is how, using the same terminal, we will be able to interact to the container. So for that, if you want to attach in an interactive way, then you are going to use an option called -i. So -i tells the Docker that the container that you have created needs to be in an interactive way. So that is where -i cannot be used separately. So you have to use another option called T, which stands for terminal. So the meaning of this is, once the container is created, attach the container in an interactive way to the same terminal or the command prompt in which you are executing this command. Okay, so remember, both are important. If you do not say -t, you will not be able to go inside the container because it will not attach. And the same way, if you do not say -i, then you will not be able to go in an interactive way because it will get attached, but whatever that you type, it will not be receiving. So that is where this two options actually go hand in hand. So sometimes you might also see people executing it by saying -it. Okay, so it will take the image, create the container, start it, assign a unique ID, and then you will be going inside in a interactive way. So the same way now, if I have to give here, you're going to say -it. Okay, so this is the command that you are going to run or execute to create a container, start and go inside. Okay, so let's start with that. So to quickly show you even before executing, now I'm on a Ubuntu machine. Oh, sorry, it got disconnected. Okay, I'm just quickly connecting again. So if you look at the machine, so the machine that we have is a Ubuntu machine, right? Ubuntu 18. So remember, and then since I have taken the free tier machine, which is based on T2 micro, so I'm going to get close to 1 GB of RAM. Okay, so this is what is available on the host machine, and the default hard disk that you will be getting for a AWS machine is close to 8 GB. So this is what I have got. So this is our host machine in which we have installed Docker. So now in this, watch very carefully. And once again, if I say host name, you will be getting back the details of your host machine, that is the Ubuntu machine. So now let's say docker run -it, and since it's a Ubuntu machine, to show you guys, I will be using CentOS so that you will feel the difference. So first, what is happening? You can see the image is not available in my machine as of now. So the first thing that the Docker does is it is trying to download it into the current machine. And once it is downloaded, it's creating the container, starting the container, and it has also assigned a unique ID, and then it has attached to that container in the same screen. So now if you look, we are not on the host machine, we have attached it to the container in an interactive way. So this is where the first thing, if I say host name, you can see it is not this, which typically indicates that we are inside a container. Okay, and this is the unique ID that it has created. So by default, the host name of the container will be nothing but the unique ID which the daemon has allocated. Okay, now how do I cross check? Because I'm still, if you think that we are in the host machine, no, we have attached and we are inside that container. So this is what is helping us to give a CentOS environment. So to cross check, I can also go ahead and say the release file. So now you can see it is saying that we are on a CentOS box. So the meaning of this is we had our host machine, which was Ubuntu, and we created a container using a CentOS image. So whatever the files is available in the CentOS, it is taking up that and creating an environment for us in this container. So because of this, until you are working inside the container, you will be feeling that it is typically a CentOS environment. Okay, so this is how the container will help us to give an environment based on what image that you have taken. Okay, so this will differentiate it. Okay, and going back to the basics, when you create a container, by default, whatever resources is available on the host machine, everything will be given to the container. That is what we were discussing in the previous session. So now if you see here, it's the same resource which is completely available for this container because we haven't given any restriction. And you can see everything is available, right? So that's how the RAM and the hard disk will be shared depending on the availability on the host machine. Okay, so this way, whenever you say docker run, it will be creating a new container and you will get attached to it by saying -it. Okay, so by this, it could have given a clarity that what happens when you say docker run. So now let's try to work in it and see what is the other differences. Now here, when I say I create a container, I'm still inside the container. So whatever that you do inside the container is kind of sealed or isolated. So that is the whole meaning of container. If you go back yesterday, I was telling you, right? The examples of the containers in shipping industry or the simple lunchbox that we were saying. So that is how anything that you do inside this container remains in this container. Okay. So the meaning of that is now, like how your host machine has a file system. When I say file system, I'm referring to the folder structure starting from root. If it is confusing, you can think it of Windows. We have C drive, right? So everything starts from C drive or D drive, and you have a whole bunch of files which is system related and your files. The same way in Linux, when I say file system, it all starts from root. The same way in Linux also we have root. So now, like how you have a file system on your host machine, every container will also have a file system depending on what image that you have taken. Okay. So here you can see it also has a bunch of files and libraries that you can use to make sure that this container acts like an environment for you to do your work. So the meaning of this is anything that now you create as a file or run as an application, it will be accessible only within this container, not on the host machine. So to show you this, I'll take another terminal and let's try to connect to the same machine. Okay. Now I'm trying to connect to the same host machine. Okay. And now to show you this, look at the difference. This is the host machine, that is the Ubuntu machine, and the file system that you have. And if you look at this at the end, this is the file system that you have inside the container. So by this, you can be clear that whatever that you do inside the container will remain only on the container. Okay, so it is not going to change anything on the host machine. So that is how it's going to be isolated. To show you the difference, let me just folder on my host machine. So this is my host machine. So now in the temp, you can see there are some files available. Now let's go to the container. In the container, if I go to temp folder, you can see you have a different content. Okay, so that is how whatever you do inside the container is isolated. Now quickly, let me create a file here. Okay, so I've created a file called test.me that is inside the container under temp folder. So if you go back to the host machine, you can see that file is not available. Okay, so this is how every container that you create will be isolated, so you can go ahead and start using them as per your need. Okay, now this way, once you create a container, you will be having an environment. So it's all about now whether you're using it for your development purpose or testing purpose or whatever that you want to run for your operations work, you can use it. But once you have completed the work, you need to go back to the host machine, right? Because we have used the same terminal or the screen first to attach to AWS, and from AWS machine we executed the Docker run, then the terminal got attached to the container. So that way we are inside the container. So now at any point of time, if you want to go back to the host machine, you can simply say exit. Okay, now as soon as you say exit, you can see we are back to the Ubuntu machine. Okay, so this is how when you say Docker run, it will create a new container and you will be going inside. And once you have done with your work, if you say exit, you're going to come back to your host machine. Okay, now just make a note of this ID. Okay, 8666. So what I'll do, like how I showed you to create a container based on CentOS, now I can also take Ubuntu. Okay, now the difference is, since the host machine is also Ubuntu, you will not be able to see the difference initially. That is why I showed you first using a CentOS image. But now if I run this, once again, you can see there is no Ubuntu image available. So it is trying to download, and then we have created the container and attached. Now in this, every time you say Docker run, a new container is created and a unique ID is given to it. Okay, so this is how now you are inside a new container which is created based on the Ubuntu image. Okay, and this will also have its own file system. So you can see if I go inside the container and under the temp, nothing is available. So this way, every container is like a separate box, and you choose what is the environment you want inside by referring to an image, and whatever that you do will be isolated. Okay. So that is first thing that you're going to understand. So whenever going forward, if you want to create a container, you're going to say Docker run, and it's going to create a container. So go inside and do whatever the specific work that you have. And once it is done, if you say exit, it will come out. Okay. Now, until now, what we understood is how do we use Docker run, and we simply saw the difference that how anything that you put inside the container is separate, because container will have a separate file system.
Hi Adam, this is Jana here. So I have a small doubt actually. So whatever the image we have created here, see whatever the available image on the Docker Hub, it is going to create it, or we wanted to, specific image, choose the image. For example, Ubuntu, whatever default available, it is going to create it, or we can choose it a specific version or something.
Okay, so we are not creating any image because there is another work which is called as image management. Okay, so typically there is already an image created and it is uploaded to the registry, which is Docker Hub. So we are just telling the Docker that for our work currently use a specific image of your need. Okay, so that is where container management is all about using the existing image and just creating the container. Okay, however, if you want to create an image, then there is a different set of activities that you have to do, which is what we call it as image management. Okay.
Okay, so we are just using available images on the registry.
Exactly.
Yeah. Thank you.
So now guys, I would humbly request everyone to go on mute because all your voices are recorded. Okay, so please kindly request everyone to mute. Now, if we move forward, you can see now if I execute the Docker run command again, and I'm creating a new container. So this time what is happening? The image is already available on my machine. So that is why it didn't download. So quickly it used the same image and created a container. Guys, I'm again requesting, I don't want to take up names, but please try to mute yourself. If I hear again, I'm going to ask you to just leave it. Okay, thank you. So here, when you create a container again, so this time it didn't download the image because it is already available. Now what happens now is every time when you say Docker run, a new container is created. So even though I have used the same image, it is not the old container, it is a new container, because first thing you can see the name of the container or the ID is unique. So this is where I asked you to just quickly remember the name. So the first container that we created started with something like 8666, right? Whereas now here the ID is different. However, this will also be a CentOS because whatever is available in the image, you are going to get everything. But on top of that, anything that you do remains in that container. So that is where when we went to the temp, the file that you created called test.me was on a different container. So that is going to be available on only that. So that is where every time you say Docker run, a new container will be created. Okay. So that is what is the next thing that you need to know. Again, when you actually create a container, so this is a Linux environment, correct? So now what happens is when you go inside a container, now let's check what is running. If you see, when you are trying to execute PS, it lists all the process. Now you can ignore this, which is the same command I've given, but what exactly is running inside this container? So it is running a bash shell, or in the other way, when you connect to a Linux machine, what happens? So the first thing is after you get connected, there will be a shell created, which is what is going to help you to interact, right, to the machine. The same way, when you say now you are interacting to this container, which is having CentOS or Ubuntu, for Linux, we need a shell, only which will help us to do a interaction. So that is where by default, now what is running is bin bash, which is a shell. So how did it run? So that's when, if you go back to the command, whenever you're creating a container, along with the image, you can also say the first command. Okay. So now there are ways in which you can specify once the container is created, what is the first command that you want to run inside. Okay. But in our case, what happened? We never told anything because the last option that we gave was the image name. So that is when there are options in the image. When you create an image, you can also tell what should be the default command that should get executed when a container gets created and the user has not told any of his option. So when you say Docker run, and if you do not pass your first command, then whatever is the default command which is stored inside the image while it is generated is what is going to get applied. So that way, when we use CentOS or Ubuntu, whoever has created the image, they have created it in such a way when you run a container from that, and if you do not specify the first command, the default command what you are going to get is bin bash. So that is where in that bin bash we are able to do a work in an interactive way. Okay, so remember, you can pass your first command. If not, what will happen? Whatever is the default command that is given in the image will be taken. So in our case for CentOS, the default command that has been given from the image is bin bash. Now, however, we can also pass our own command. So let us try to do that. So just to show you, now let's take CentOS, and then following this, whatever I pass will be the first command. Okay.
Adam? Hello?
Yeah, go ahead.
Yeah, actually, as you said that CentOS, actually we are pulling from Docker Hub, right?
Yes.
Yes, by customize, how can we do that one? I mean, for example, for the company, they're given the task for unbuilt products, I have to make an image Docker. So how can we proceed like that?
Is your question on how to create an image, or is your question that how do I download an image from a different registry?
Yeah, different register like that. In Docker Hub, I mean, for example, we have CentOS in Docker Hub. By default, the Docker Hub has been created by some developers in the Docker, right? We have to customize, like we have to create a new one, which is not available in Docker Hub.
Okay, I think you're again putting both the questions, but anyway, if you have to create an image, that is a separate process. But let's say you want to use a image not from Docker Hub, but from your private registry. Then when you execute the Docker run command, instead of directly telling the image name, you are going to actually give the location of your registry / image name. Okay, so this is how you will be working in a real time. However, if you do not tell the registry, then it will take the Docker Hub as default. Okay, but anyway, as you go forward in an organization, if you see, you're going to specify the registry and then the image.
Is it mandatory registry?
Yes, because when you work as an organization, you will not be using public registry, because the images that you create in your company will have your company's application or product that you cannot take it outside your organization or put it into a public place. So that is where every company will have their own private registry, which is mandatory. Okay, but for our
Yeah.
practice, we are just trying to use a public registry, which is Docker Hub.
Yeah, thank you. Thank you.
Adam? So if there is no registry, like if the environment is in cloud, so will there be a registry or it will be pulled from Docker Hub?
If you do not tell a registry wherein your registry can be on a cloud or on premises, that's up to your interest. But when you do not tell anything, then it will go to the Docker Hub by default.
Adam,
Okay.
Adam, my question is, when we download image from official site, it is in GBs, but when we download from Docker Hub images, it is in MBs. How is it possible?
Okay, so again, it's a good question, like registry. Now go back in the last class, I was telling you image is nothing but layers, right? So just like the example that I gave was sandwich. Now every sandwich that we eat will not be the same because the layers will be different. So the very simple differentiation between what you said is the image that I took is also a small image because it has only small amount of or very minimal layers. Okay, so that is where the size of it is less. But as an organization, if you go, they will be putting many files which is needed for your application, or in fact the application also to be available. So that is where, as you have more and more content and more layers in the image, the size of the image will be big. Okay, because typically for us to practice, if I have used a huge image, downloading itself will take a long time. So that is where, depending on the image that you take and what are the layers that it has, the size of the image will be varying. Okay.
Adam?
Yes.
Actually, we are running that CentOS image, right? We are getting unique ID. Can we change the unique ID, that host name, into user friendly? Is that possible? But because we can't
Okay.
remember the unique IDs.
Okay, I'll give a solution for that. But to answer your question quickly, that's again a good question, that you cannot change, because similar to Git, in Git, what do you have? You have a commit ID, which is created as a checksum, correct? The same way, it is not just a random number which is getting created. So it is a checksum. So that way, at any point of time, you will not be able to change the ID. However, you can use the concept of tag or name just like Git here also. That I will get in the next topic. Okay. For now, to remember, you will not be able to change.
Okay. Adam, I have one question. This is regarding that once we create the Docker, and then once you create that container, we'll do some operation in that container, and if we want to keep that live, and if we exit, the container will go and we will lose that whatever we have done in that container. So if you want to keep that in live, what we have to do?
Okay, it's a good question. I'll be talking about all these things little later, because the way that we are going, we are just seeing how to create, but we still have so many other options to see. That's where we will be answering all. Okay.
Adam,
Adam,
this command,
Yeah, go ahead.
Yeah. So in here you're passing the command bin slash shell, right? Sh. Here also this another image, I mean another container will be created, or
it is not the container here. So now if you go back to the basics, this is where I was trying to tell you. When you execute docker run, it will create a new container. Okay. And to create that container, we are using the CentOS image, so that once the container is getting created, it will take the copy of all the layers that you have here in a read write fashion. You will be able to work. And now once you created the container, if you are going inside the container in an interactive way, what is the first command that you want to run? So the default command which this image uses is bin bash. Now instead of that, I can run my own command, or I can also run my script. So if I want to do that, then after the image, you are going to specify what is that command or script that the Docker should run. So that way, it created the new container using this option. And inside that, the first command that it is executed is bin sh. So in fact, if you see, whatever you are seeing now here, right, it is nothing but a sh shell. Okay, a bound shell. That is what. So if I don't tell, by default, the CentOS image will allow us to create a bash shell. So now just to show you, I can use a default command, or I can also specify my own command. Okay.
okay. So the next time when we log into the container, by default, this first command will be this one. It will execute the shell prompt.
I'll talk about that as we move forward. Okay. So let's just focus in this way. Again, it's just a
Hello.
request. If you have
Adam,
one
I
second.
have one question.
1 second. Try to understand. I'm trying to cover all the scenarios that you are asking will be covered. So the only thing that I'm asking you is try to understand related to the topic that I have, because that's the reason most of the time I'm saying just wait, I will answer your question. Okay. So we are just going in a proper workflow or a proper flow so that you take one by one, because I cannot give all of them in just one command, because my point is not to just give you that command and finish the session. I started here for a purpose that every one of us will understand. So that's the reason I'm getting in internals of every options, every command, so that you will get. So all your questions will be answered. But yes, go ahead. What's the question?
Suppose every time we run we create a Docker container, a unique ID will be created. Okay, so is there a way to get whatever the unique means Docker container IDs which was generated? So we need to note it down, and if we want to go back, we need to use the same ID to go back to that container previously whatever we created.
Yes, we will see those options again. As I said, I'll be covering all those, but I'm just trying to show you one by one, wherein first it's the difference, and then we will come into all those aspects on how do we see that ID, how do I again go back. Okay, there's plenty of options out there.
Okay, thank you.
Okay, so here, what I was trying to say you is, if you do not tell a command, by default, Docker will take whatever is available in the image. So that way, now if you can see, we created a new container and it has a unique ID, and it also specifying what is the first command that you want to run. Okay. Now, just to show you the same, now what is happening is when you say exit, you are coming out of the container. So in that way, now if I go back and ask you, how many containers did we created from the beginning of the session? There were like 3, 4 containers, right? So what happens is, whenever you say Docker and go inside the container and say exit, it actually stops the container. So it is not deleting the container. It's just like you are coming out of a machine. Okay, that doesn't mean that the machine is getting deleted, right? The same way, now when you say exit, what is happening is the process. So if you see, when I say bin bash or bin sh, it is a process, right? And look at this. What is the process? This is the first process. So what happens now is when you say exit in this process, the process will get stopped, right? By default, if you are sending a signal or a SIGHUP, or basically when you say exit, it is going to stop the process and go back to its parent's process. So that way, what is the parent process for this bin sh or bin bash? This host machine, right? Because there is a shell we are right now connected, and in that shell, we executed the docker run command, and inside that bin sh was running. So that way, when you say exit, whatever the process which is running inside is getting stopped. And in that way, this is the first command which is getting run. And the process ID of this also is 1. So that way, when this itself is gets stopped, there is nothing else running inside the container. So now the default behavior is when nothing is running inside the container, Docker will automatically stop the container because you don't need it, right? So that is where the difference between VM and a container comes back. So remember this, if nothing is running inside the container, then the container will be in a stopped state. So if we want something to access from the container, we need to make sure that there is an application or a process running inside the container always. So that way, whenever we said exit, what was happening is we were typically trying to stop the first process, which is the parent process. So that way, if this itself is not running, we do not have anything else running inside the container. So that is where the Docker went ahead and stopped the container, and because it stopped, you came back to the host machine. Okay, so remember that, it's very important. So regardless of what command you are giving, because you can give a command or you can run a script here also, or you can directly call an application, you can have all these options. But unless and until something as a process is not running inside the container will be stopped. So that is where every time when we did a Docker exit, it stopped the container and it came back to the host machine, and it is. So this is where at any point of time, if you want to see what are the containers running on your machine, you can go ahead and say docker ps. Okay, so ps refers to the process which Docker has created, which is nothing but each container. Because internally, if you go back to previous session, I was telling you container is nothing but a process, right? So that way, when you say docker ps, it will try to show you only the running containers. Now, as of now, we do not have any containers running because all the containers we did the exit, so it went to a stopped state or exit state. So if you want to see all the containers, whether it is running or not running, then use the option called -a. And now you can see the output wherein it clearly says there are 4 containers that we created, and all the 4 of them are in exit state because when we did the exit here, it stopped. So this is how, when you stop the first command which is running inside this container, there will be nothing running. Because of that, Docker will automatically stop. Okay, so keep this in mind. So that is how when we did exit so far, we were coming out of it because of the reason that you are doing an exit on the bash shell or the sh shell. And when you say exit on a bash or a sh, it is going to stop and go back to the parent. So that is how, now if I do an exit here, what will happen? It will go back to the Ubuntu user, right? In this, for example, here. See, it's switching me because from the default Ubuntu user, I did a sudo su and then came inside. So that is where it created another process. So the same concept over here also. Okay, remember it. And when you run this, you can see every container has a unique ID, and it also specifies which image that has been picked up and what was the command. So you can see now in all these previous containers that we had created, the default command was bin bash. Okay, so this is where you can choose your own command that you want to run. To understand, let me run a command now wherein I will say docker run -it, and I will use CentOS, and let's say I will give a command called echo. Now, let's understand what happened. See, I said docker run, and I am using the CentOS image, and I'm executing my first command as echo hi Adam. So what ideally Docker would have done is it would have created a new container based on CentOS, and in the interactive way, inside the container, the first command that it would have executed is hi Adam. But what is happening is when you run a command like echo, as soon as it prints on the screen, the work of this is over. That means this process will automatically get stopped after printing on the screen. So now the question comes is, after this, is there anything running inside the container? No. So that is where automatically after printing the screen, the container got stopped. This is the reason why the startup command should always be a script or an interactive shell like bin bash or sh. So that is why they have set it as default. If not, what happens when you run something like this? Until this is available, the container will also be available. When this first command, whatever that you're giving, completes its work, there is nothing else running. So that is where container will get stopped automatically. So now if you go back and say docker ps-a, you can see there's a new container created. So this is where it is quite important to understand what is the first command that you're giving, and as long as some process and the first command is running inside the container will be running. If not, it will get stopped. Okay, remember this, which is quite important. So
Adam, I'm really sorry to interrupt. Lakshmikant here. Could you please repeat this point? I just didn't get it. Why the first command is that much of significance here?
okay, see, whatever you're running as the first command will take the process ID 1, because that is the first command running. Now in a Linux machine, if you kill a process which is having process ID 1, what will happen?
The process is gone.
But what happens to the machine?
The machine will be still there. You're just killing the process inside the containers.
You kill the process ID 1. What happens? Forget about container. So in a machine, when you start, which is the process which will have the process ID 1?
The first process, the first command.
Yeah, what is that? Anyone?
Okay.
It's a basic. Here.
Shell will be available.
The process ID of the shell.
init process.
Exactly. So when you start your machine, your init process will take the first process ID, and typically everything followed it is being used by this. So now when you want to reboot, when you ask your system to reboot, what typically the kernel would be doing is it will be stopping this process. When the parent gets stopped, everything gets automatically stopped, and that is where your machine is getting restarted. So that way, if you try to stop this, there is nothing in the machine, so the machine will get switched off. The same way, when you try to create a container, and if you are trying to give a command, this command is going to take the first process ID, and as long as this process is running inside the container is also running. When this is not running, then there is no process running inside the container, because the parent process is the one which handles everything. Now if this process itself is not running, then ideally there is nothing else running inside the container, so the container will get stopped. Okay, however, this is where if you use a shell like bash or sh, this is not a shell which will just run and stop. It will go into a interactive way. So that is where when you are trying to use -it, you have to use bin bash, so that now if you actually look what is running, there is a bin bash which is running, and that is what allowing us to do a interactive way, and that is where I am going inside the container and I'm typing the command. So without a shell like bash or sh, I will not be able to get the interactive session. And since this is running, you are feeling that you are inside the container. But as soon as this gets stopped, what happens? There is nothing else running inside the container, and then the container will get stopped. So that is where when I say exit, you are currently running or working in this bin bash. So that way, when you say exit, what you are actually doing is you are stopping this process. So when I stop this process, there is nothing else inside the container. So the container gets stopped and you're back to your host machine.
Okay. Is this a standard practice to make sure you run an echo command and make sure the processes are still running?
No, all these things I'm trying to show you, but this is where you need to understand it's up to the interest of a person wherein you can run some application or some other command. But for you to first understand and know the logic, you need to know. So that is where now, if you run this, you can see the difference. It is creating a bash shell and you're inside. But if I run this command completes as soon as it gets printed, right? So that is where just to show you the difference, I'm using echo.
So generally, when I say exit, the process one is killed basically, right? That's what is usually happening.
It depends. Try to understand again the same point. This is the only process running, and now whatever the command you are typing on the first process. So that way, when you are exiting this process, obviously there is nothing else is running. So the major point that you have to take back is the first command, whatever you are running, which could be a command, or you can run an application, or you can run a script. It's up to us. But when you are running, as long as that first process is running, container will also be running. If this first process has been stopped, the container will also get stopped. So that way, when we use bin bash, all these commands, whatever I'm typing on this bin bash only, right? Because I think you have to go back to your basics of Linux, where bin bash is nothing but a shell, and as soon as you connect to a machine or a container, that is what you are working in. So now if I do exit, I'm actually stopping this process, and that makes the container also to get stopped.
Adam,
and at the same time, if we run that echo command and make sure the process ID one is assigned to something else, then if you say exit, the container or the things that are running in the container won't be stopped.
Yeah, you can run something. That's what we will see later. But now, in this example, if I say echo, the echo command is the first command. Now, the echo command will be allocated the process ID 1, but the difference is bin bash will stay there because it's an interactive shell. That is why you are going to, or you are able to go inside. But when you say echo is just something which will run immediately and finish. So as soon as it completes, after the print on the screen is completed, there is no process running inside. So that is where you're not feeling that you're going inside. So that is the major reason. If you want to go inside, there should be some process running. So that is where you cannot use any such command. So the only option available for that is using an interactive shell like bash, which will not stop until you come out of it. Okay, so when you say bin bash, even over here, if I say bin bash, what happens? It will actually create a new process. You might be thinking it's not doing, but typically if you go and check the process ID currently, you will not be on the same shell. So that is what is happening here.
Another session, basically what you mean of bin
yes,
bash.
It's not a session, it's called as a process. So again, going back to Linux, every time you execute a bin bash, it creates a new process. In fact, every command that you run, it will be spawning a new process. Okay.
Can we do a PSEF command now that you have run bin bash again?
Yes, it's on the same. See, a process doesn't mean that you're running on a different machine and PS will be different. It's all the same process which is running on the host machine. It's just another process. That's it. If you go, you can see there will be at least 2 SH running. Okay, so one would be typically coming from your first login, and there would be another SH that you just did now. So this is what is the difference.
Can we just grab it? It's confusing like this of 2 different processes of bin bash.
Okay, you can see depending on what you did. This is the bin bash that I did now, but typically before that, when you logged into a machine, that's what again you have to go back to your Linux basics. When you log into a machine, there would be first one shell which will be run. So that is again by default bash. So this is one bash, and that is trying to create this which we run. Okay.
So I understand 2 points here. One is if you want to exit, if you exit from a container, you want the contents of the processes in the container to be up and running, and that is what you're trying to achieve here by running some command. Yeah.
It's a little different. I'll just repeat the same thing what I said. It doesn't
Oh my
matter what
God.
you're running. It's
I
up
think
to us.
okay.
I think, see, that's what the whole problem is. You need to go back with the Linux basics, because if we get into Linux, it'll be whole different. But I'm keeping it simple again for the benefit of everyone.
Yeah.
You can choose what command you want to run, whether it could be a command or it could be a script or it could be an application. But the simple point is, whatever you run here will be the first process running inside the container. And as long as the container is running, or as long as the application or the first command that you're running is available inside the container is assumed as running. If this is not running, because the first process ID is assigned to this, and when there is nothing running inside it, then obviously the container will get stopped. So this is the very reason, if you want to interactively go inside a container, you need a process like a bash shell. This is exactly similar to how, if you want to connect to a Linux machine, whenever I connect to a Linux machine by saying SSH, what do you exactly get is a shell, which is a bash shell. And that is what is happening here. So make sure that going forward, if you want your container to be always running, then there should be something which is running inside. If not, container will not run. Okay.
All right. Thank you.
So Adam, I mean, just this is a repetition, but just want to make sure. Any command, that means any, as you mentioned, that echo or ls or any command we can put, but just to keep going on, bin bash is the command which we have to use, right? Even like ls can also be used in case.
Exactly. If I run ls, what will happen?
It will show all the available.
Run CentOS. What is it doing? It will run ls as the first command, and you can see it is giving you the list of directories, but after that ls is completed. Is there anything else running inside the container? Nothing is running, because this is not an interactive process or a shell. So that is where it has stopped. So now if you go back and say docker ps-a, you can see that it would have created a new container, and the first command that you run was ls. So this is where you need to choose, but it's all going back to the basics. The whole reason why I'm trying to show you is you need to understand what happens when you run. Okay.
So when we are using bin bash, we are also entering into the container as well.
Yes. Again, that is your basics, because when I told you you are going to attach, without the bin bash you cannot attach. The reason you are able to attach is because there is a interactive shell running.
Yeah, got it.
Okay. So now, if you saw that the difference that I was saying is, depending on the first command that you're giving, unless and until nothing is running inside the container will get stopped. So this way, every container that you create will be unique, and only the container which is running is what you're going to see. Now, at any point of time, if you want to start a container which is already stopped, okay, so then you are going to say docker start and then the container ID, because the only way that you will be able to access a container is only when you know which container. So for that, you're going to use the container ID. Okay. So let's see here. When I go back, so there are plenty of containers. Okay. Just to show you, I will take the very first container. Okay. and I'll say docker start. Now let's not worry about what it is doing because there is something else that I want to show you. So now if you see, I have executed a command called docker start, which means there is one container running. So that's where when you say docker ps, you can see it displays. So the difference is when you say docker ps, the containers which are running is what it is going to show. Okay, and then when you try to say docker ps-a, then it will be showing all the containers. Okay, so that's the basic difference. So at any point of time, if you want, you can start a container and you can also stop them. Now suppose I want to stop any container. Okay, then if you know the container ID, then instead of saying start, you can just go ahead and say stop. And now if you go and say docker ps, you will see that it's not displaying. Okay, so these commands will be handy in some cases, but we will try to see it little later as we know more options. But for now, remember, ps will show only the containers which are running, and -a will show everything. And at any point of time, you can start a container or stop a container. Okay, now when you say that you have containers, now just as you start moving forward, there will be many containers. Now it will be very difficult if you want to refer to a container. Okay, so what happens here is, at some reason, if you want to go back to existing container, because every time I cannot just say docker run and create a new container, and when I exit, and again if I say docker run, if I keep creating in this way, then there will be hundreds of containers. So if you have a requirement where you want to go back to a container, you need to first identify it. So that's when, for you to identify a container, either you can use the unique ID. If not, what will happen? You can assign a name and tag to it. Just like in Git for a commit ID, how do you give a tag, right? If you go back to the basics, the same way in container also, you can give a name which is comfortable for you to remember, which can be changed later, but you cannot change a container ID. So that is where when you are creating a container, you can use an option called name, and you can give a container name. Okay, so this way the unique ID will be assigned to the container by the Docker. At the same time, the name will be given by you, which you can use it for assigning. So now if I take the same example, I can just say name test00, some name to identify. So let's try this. So when you say docker run -name, let's say it says 00, and I want to go inside interactively, so I will be saying -it, and then the name of the image, and then what is the first command that you want to run. Okay, so now you will know the difference here. So the name for the container, which way that you want to interact, and then the name of the image followed by the first command. Okay, so now here if you see, it's a new container with a unique ID. Okay, so now here what I'll do is I'll create a new file called test00, so that we know that this is the new container in which we have created. So when I say exit, what happens? This container is also stopped, but when you say docker ps-a, you can see for this container there is a name given to it, so you can use this name. So that's when for all the commands, either you can use the ID or the name. Okay, both are the same. So if you know the ID, you can use. If not, you can use the name. So this way, now if there is a container which is stopped, and if you want to go back to it, just like a machine, first you need to start it. So this is where in my case, if I want to go back, then I can say docker start and the name of the container. And If you go ahead and say docker ps, you can see that it is trying to start and there is one container running. Okay. Then next, what happens is, now again, it's like a machine. See, if there are multiple VMs, if you want to use, first you will start it. But after starting, again, you have to go back inside, right? So this is where, when we said Docker run, the Docker run itself was doing a attach. But now I'm not going to use again Docker run, because when I say Docker run, it will create a new container. But what we need now is the container which is already created, we just have to attach, because the container is there, it has been started. The only thing what we have to do is attach. So for that, we are going to use the command called attach. Okay. And now remember, when you say attach, typically it requires that while you are creating the container, you should have given the -it. If you have not given the -it, when you say attach, it will not be able to take. So that is where, now if you go back the basic, when you say docker run, the docker run itself was doing all these things together. Okay, that is where I said there's one command which will do multiple things together. So now if I want to go back, then all you have to say is docker attach and then the name of the container. So you can see you're back to the same container, and to cross check, you can go inside temp folder and you will see this file. Okay, so this is when what you need to know is to work, what is that first as a container you need. So for that, what is the image that you're going to take? And again, from where you're going to take, 1 minute guys, from where you're going to take. Okay, and then for that container, if you want to go in an interactive way, then you're going to use the option called -it, and followed by that, in the container, what is the first command that you're going to run. So with the combination of all those things, you will be able to create a container, go inside and work, and then once you have completed your work, you can come out by saying exit. And at any point of time, if you want to go back to that container, you need to say start and then attach. And for all these things, you can use the container ID or the container name. Okay. Yes, any questions?
So if we just say attach, it won't start in the background, right?
No, you need to first start and then attach. Both are separate options.
Is there something in a single command we will be able to do that on the go? Start at the same time attach?
You are going to do run. Other than that, you have to do start and attach separately.
Sir, I don't want another container to be launched.
Yeah, you have to do start first and then you have to say attach.
Okay.
Ram,
Yeah.
Yeah. Suppose if we use the attach command, what is the meaning for that? Means we will go back to the same container. We can use the attach command, correct?
Yes. If there is a container already available, which has been started again by you, you're attaching, which is the sense you're going back to the same container, which means you're reusing a container. Okay.
Okay. I mean, after stopping that container also.
Correct. But after stopping, first you have to start it and then you have to attach to it.
Okay, means any other meanings of attach. When we go back for the content, same container, we can use the attach. Means no other meanings of attach, right?
Yes, first start it and then attach.
Yeah, got it. Okay, thank you.
Yeah, Adam, when we start the container, what process will be running in the container? Still, we are not running anything, right?
Okay, that's a good question. So it all goes back to what is that you have given in the Docker run. So in the Docker run, whatever you have given, that is what will be running when you say Docker start. Okay, getting it? So every time it goes back to the first command that you have used to execute it. So at that time, whatever it has picked up, that is what it will be running when you say Docker start. So that's where it's quite important for you to know what is the first command that you want to choose.
So
Okay.
can we pass a different command while starting the Docker?
Yes,
Like
as an
I don't.
example, yeah, you can pass. That's what I was telling you, right? I can pass echo command, or if you go back, you can see that I was passing different commands. In the previous example, I passed what? Bin bash. Instead of that, I can pass echo command ls, or you can also pass your own script. You can pass any command or a script or an application that you want. It's up to us to choose.
While starting the Docker, so while created the Docker, I used different command. So now I'm
No, it's
running
not
different
possible.
command. Oh,
It's not possible. It will always choose whatever that you have chosen to execute by saying docker run.
okay. Thank you.
Okay. Now the last thing is, yep, go ahead.
Sorry, one doubt. We are starting the container and then we are attaching it. We do some changes. First, suppose we are deploying any var file or so, and then we are starting the process and we are exiting the container. So the process will be running or it will stop.
Yeah, I'll answer. I know what you're trying to ask. We'll be talking about that in the next topic. Okay, just give me 2 minutes. I'll restart.
Okay.
So now, at any point of time, if you do not need a container, you can just go ahead and say docker rm. But you need to make sure that the container is stopped, because you cannot just delete a container which is running. Okay, the same way, when you want to attach, first you need to start the container and then attach. The same way, when you want to delete a container, you need to make sure first it is stopped. So that way, when a container is stopped, it is available for you. No matter when you come back, it will be available. But if a container is deleted, then you need to understand that all the content inside the container is also deleted. Okay, so that is where you need to make sure to keep the container as long as that you want, whether it is running or in an exited state. But if it is available, you can reuse. If the container is deleted, then you will not be able to get back, or you will not be able to get the content that you had inside the container. Okay, so by this, now at least
One quick question. You have started the one Docker with echo hi Adam, right? So when I
yes,
start the same container, Docker start and container ID. So it will start and it will just say echo, I mean hi Adam, and it will come out, right? Since the first
exactly.
command is hi Adam. But I mean, is there any way? As per run command, it will show, it will echo, and it will come out. But is there any way I can retain there?
No, it's the same someone was asking some time back. No, you cannot. So this is where you need to understand that when you are creating a container, you should have given. Because now if you need to know, see, container, or what we call it as usually epiphermal. Okay, it's not a big deal for me to delete and create another container. So it's not a big headache like a VM. So if you by mistake gave a command called docker run and echo, fine, go ahead and delete it and try to create a new container, because you can have the same image and create as many containers or as many copies that you want, which is going to take just less than a second. So that is where it's quite important for you to understand what is the first command. If something goes wrong, it's like delete the container and create a new container. Okay.
And probably you are going to cover in the next slides, probably, I think so. How do we recreate or copy the containers?
Come again?
How do we recreate or copy the container? Say you created a container and you have done so many works. The way you created temp files or something, some scripts and all. I want to have the similar container again. Recreate
Okay.
or copy.
So that is part of the image management. Okay. So ideally, for understanding, I mentioned that you can copy, but you cannot directly copy a container, just like your VM. Can you make a clone of a VM directly? No. So you need to take an image of that and then create a container. So that way, if you have a container and if you want to make a copy, then you need to first create an image of that container so that all the contents of the container is stored as an image. Then using that image, you can create as many containers that you want. Then it will be exact copy of your container. Okay, so that is the only possible way. Other than that, you cannot copy a direct container.
Thank you.
Yeah, Adam.
Yes.
Hello. Yeah, when you
Yes,
are
Guys,
running the like container, when you are
guys,
like
guys,
exiting,
guys,
whether it's
guys,
stop mode
guys,
or
guys, guys, please. I'm really sorry. I think we are taking too much of time. I appreciate that you guys are asking question because like I said, I'm recording and all these things will be in there. So what I'll do is let's take another 15-20 minutes and I'll try to cover all the topics that we have because that will answer all your questions. Then I'll be open for question and answers so that you can ask all the questions because I see that's the same question being repeated or it's more basics that you're not understanding. Let's not ask others to wait for that. Okay, I'll humbly request you to just stay back for another few minutes so that I will cover all the flow and you will get all your answers. And still, if you have any questions at the end, we will take up a question and answer. All right.
it's a good idea. Thank you very much. Please.
Yes, Adam, go
Okay.
ahead.
Yes, please go ahead.
All right. So until now, what we understood is when you say Docker run, how is that you're going to create a container? And then how is that you're going to typically start, run, right? Wherein you can choose what is the first command that you want to run. So we were just trying to see this option over here. And then additionally, this. Now let's come to another real time. Now, if you are creating a container where instead of directly running something on your host machine, you're going to create a container, put that image and run inside. Okay, that is what you are trying to do. But let's go back for a minute and think, instead of running this basic commands like echo command or bin bash, I am interested actually to run some application inside the container. Okay, so now my requirement is, let's assume that I have a Windows machine. Now on a Windows machine, I want to start a application which is based on Ubuntu. So now I can use Docker, create a container, put Ubuntu image inside it, then the container will be acting like a Ubuntu machine or an environment. Now I can go inside the container and then run my application. Okay, now that solves the first purpose for me. But if I want to allow others to access my application, then what happens here is, as long as the container is available, people will be able to access my application, or in fact, you can also access the same application. But what happens when we are using the interactive way? You will create a container, you will go inside it, and you will start the command or run the command. Now, what happens at any point of time if you are trying to come out of that? That is, when you go inside the container, at any point of time, if I try to come out, what happens? You are actually trying to stop your parent process. So, if you try to stop your parent process, then what happens? The container is not running. But what do you mean container is not running? Your application is also not running, correct? So that is where, if you want a container not just to go inside, do some activity and come out, but if you want a container inside which there is some kind of application which is always running, then how do you make sure that it is running? That is one of the question. And at the same time, you should be able to come out of that without tampering it. So that is when there are two types of way that you can start a container. The first way is interactively. The second way of creating a container is what we call it as a detached way. Okay, so what do you mean by detached? Now, detached means my interest is not to go inside the container, but in that I want to run some application. So that is where I can create a container which will be running in the background, and I can tell what is the application that I want to run without going inside. So now imagine this. I have an application. I know where it is available inside my container. If I create a container in a detached mode and give the first command, what will happen? Container will come up, and inside that, whatever the first command or the application that you're giving will be running. Now in that, you will not be attaching to the screen. So that way, if you have a requirement where you don't want to go inside the container, but the container should be running something inside, then you can use a new option called detached, or we say it as -d. Okay, so what this will do, it will again go back to the basics. When you say -d, it will create a new container, start a container, but it will not attach to your screen. Instead, it will be running the container in the background. But whether it is running in an attached mode or a detached mode, when do you say container is running? Only when there is some process running inside the container. So that is where, when you want to run a container in a detached mode, you should be giving the command which will run whatever application that you have inside the container. So that is where you should choose your command should be in such a way it will trigger that application, or it could be a script which will set up that and run the application. So that is where in real time what you are going to use a lot is the detached command. Okay, now to understand this, what I'll do, typically, let me just try to write a simple script. Okay, now since most of you looks like doesn't have much of basic of Linux, so if I take a application, it will be difficult. Now what I'll do, now I'll just take a simple script in shell, so that if I run that script, it will be running on an infinite loop. So you can consider this as a machine or as an application, because what is an application? It will be running. So that way, now what we will do, I'll try to create a container and I will run a script inside it, which will be running in an infinite loop. So as long as the script is running, you can consider that the container is also running. Okay, so let me just simply type it. So this is where I'm just trying to say a while loop, and I'm giving the condition as true, which means always it will be running. And here, okay, I'll just say hello Adam, and I'll sleep for some 8 seconds, let's say, and then done. Okay, so now watch this, what happens. So if I just directly run this, so you can see this goes into an infinite loop where every 8 seconds it is going to just keep printing the string whatever I have given. Okay, so that now when I want to create a container in a detached mode, let us use this, so that now instead of giving bin bash or echo command, let us give this, so that now this is like an application for me. So as long this is going to run, my container is believed to be running, because now if I give this itself as my first command, then the Docker will take this and run, and as long as this is running, you will know that the container is also running. Okay, so for this, now let's try to construct the same command here. So now if I go back, I will say Docker run, and I'll give a name for it. So I'll call it as test01. And then what is the mode? So this is where we will say -d, and followed by what image that you want to run. Now let's say CentOS, and then followed by that, what is the command that you want to run. So now you can see I'm using this script as my first command. Okay, so now it's all the same, wherein we are trying to move into the next step. So now watch this. So what happened? It didn't download the image because it's already available. Then it created a container, but we didn't go inside it. Why? Because we have given in the detached mode. And now to cross check, let's go ahead and say Docker PS. It just got disconnected. Anyway, now if I say docker ps, you can see that there is a container which is running in the background, and the name of that is test01, and you can see what is running inside it. So this way, now if you have an application that you want to run, then you should not be using -it, you should be using -d, because in real time this is what you're going to do for the most of the cases. Because when you have an application to run, all you're going to do is simply use the detach mode. But whether you are using attach mode or a detach mode, you need to tell a first command, and in that, if it's a detached mode, there should be a particular application or a process running. So as long as that is running, then the container is considered to be running. Okay, so that's the basic difference between attached and detached. Okay, now in this, what we understood here is how do you create a container in a detached mode, and to check whether it is running or not running, you can see by saying a docker ps. But still, what happens is, if you want to see what is happening inside the container, because when you have attached it to your screen, then you would be able to see whatever it is printing. But now how do I know what is exactly happening inside the console of this particular container? So if you want to see, then there is an option called docker logs. Okay, and if you want to get live logs, just like how you have tail-f and you take the live feed, so if you say docker logs-f and the container id or the name, then what happens? Whatever is getting printed inside the container's console is what you are going to get in this particular output. So see what happens when I say docker logs-f and the name of the container. So you can see whatever is getting printed inside the container is what is getting printed on your screen. Okay, so this way, without going inside the container, you will be able to see what is happening. Okay.
Yeah, hi Adam.
Yes.
Yeah, for example, in real time, this is just you are printing like hello Adam. Some like web applications are running. Then in that case, how can we see the logs actually?
Yeah, if your application is giving the output to the console, then you will be able to see. If not, that is the next question that I'm trying to answer, okay, which I'll tell you with the options. But as you said, if my application is printing anything on the console, then I can use docker logs. But as you are asking on the right question, there will be some requirement where I want to go inside the container, because like what you said, if there is an application which is not printing on the screen, but it is storing some log inside container in some location. So this is where you will be having a requirement in which you want to go inside the container. Okay, so at any point of time, if you want to go inside a container, now how will I go? So this is where now there are two ways to do it, because if there is a container which you have created in a detached mode, you cannot use attach to it. So when you have a requirement in which you want to just run some command on a container which is running in the detached mode, then you can go ahead and use docker exe and then the container name, and followed by that whatever is your command. Okay, so now let's assume this container is running and I want to check something from that. Then typically I can say docker exe and the container name and whatever is the command that I want to run. Okay, now I can run it this way, or I can look at some content. Okay, or I can go ahead and run. So now what is happening, if you see, in all these cases, you don't have to attach to the container. Okay, because when you attach, the problem is you have to again stop it at some point of time. So that is where when you have a container which is running in a detached mode, what we will be able to do is use the Docker exe and make sure that whatever the command that you want to run, the daemon will run it instead of you. So that is where all these commands are executed inside the container without attaching. And that is where Docker exe will be useful. Okay, so this is when you have the container running in the detached mode and you don't want to go inside. So you can run as many commands that you want. But in this itself, if I have a requirement where I don't want to just run some command, but specifically I want to go inside. The same example like someone was asking, I want to read a file. Now to read a file, I can say cat, but what if I have to read multiple files? Then my requirement now will be to go inside the container. So if I have to go inside the container, then what will happen is it's again not possible because I cannot use attach. So that is where in the same exe, what you can do is you can use a hack. So the hack will be, you can say docker exe and you can add an option called -it, and then you can give whatever is the container, and then whenever you say -it, you need something to be running inside the container which is interactive. Because right now what is running inside the container is a shell script. This is not interactive. It is something which is running by itself. So now if I want something interactive, I can go ahead and say bin bash. So what is the meaning of this? In a container which is already running, you are trying to create a new shell and use it to go inside the container interactively. So this way, on a container which is running in the detached mode, you can see I can simply say docker exe and the name of the container and bin bash. So what happens? On the existing container, I'm telling to run bin bash and that give me the access interactively. So this way, now you can see I'm inside the container and you can see this container has the process ID 1 of the command or the shell script that you ran. However, the bin bash that I ran is not the first command. So this is where I can safely go inside, do my work, and once if I want to come back, if I say docker in the exit, then what happens? It is exiting this process because whatever the interactive shell that you got is bin bash. So when you say exit, it is going to typically exit the bin bash, and now your process is still running, which is the parent process. So because of that, if you go back and see, it is quite safe. So that is where in real time you're going to choose whether you want to go inside the container, or most of the use cases you will be requiring containers to run some application. So when you want to do that, you will be using detached mode. And when you say detached mode, what you need to know is you need to give a startup command in such a way that there is some application which is running inside. Okay, so as long as that is running, the container is going to run in the detached mode. And at any point, if you want to go inside a container, then you can use the docker exe -it and bin bash. If not, if you want to just run without going inside, then you can just use docker exe. Okay, so this is how you can ideally create a container of your choice and tell what image to use, and you can also tell whether you need an attached mode or detached mode, and you can tell what is the first command that you want in it. Okay, so there are plenty of options for that. Okay, now I'll just give few more options so that it makes it complete. So this way, now when you say that you want to create a container, the things that you need to decide is what's the image that you want to take, and then whether you need it in attached or detached mode. Try to give a name to the container so that it's easy for you to access, and then what's the first command. If you do not give the first command, it will take the default command which is available on the image. Okay. Now, especially when you're trying to create a container in a detached mode, now what happens is when you run, if you want to set some environment variable, how do you set an environment variable in Linux? I can just say export my variable name and the value of it, right? Something like this. Now, what you want is, suppose if you are trying to create a container in a detached mode, and while you are trying to run some application, you want to set an environment variable. Then typically you can use your docker run command and try to pass the environment variable during runtime. Okay, so how do you do that? So you can use an option called -e. So in this, you can typically use -e, which will say pass a environment variable, and for this you can give the name of the variable and its value. Okay, so an example will be like, if I want to create a container, right, now simply I can say docker run -it-e. Let's say my name is Adam, and I can say CentOS. Okay, now just to show you, so it's created a new container. But anyway, now if I go inside the container and if I try to check the value, you will be able to get. So this way, whether it's an attached mode or it is a detached mode, if you pass, what will happen? When you create that container, inside the container, the environment variable will be available. So that is where you can choose to pass a particular value, and whatever the command or script that you're running, you should write it in such a way that it will be using this environment variable as per your need. Okay, so this is a way where you can pass a environment variable. Okay.
Yeah, Adam, can we pass like a number of variables, or like is there any limitation?
Yeah. You can pass, again you can say -e and you can pass multiple. If not, you can actually take a file and put all the environment variables in a file, and you can also pass.
I have a scenario like Adam, like while running the container only, we can pass one shell script, right? But shell script can run with the multiple parameters, right? How can we run in that case?
The same thing here, like what I said. See, instead of running a command, you can run your shell script. Suppose I can run a shell script dot test.sh, and I can pass my arguments here. Argument 1, argument 2, that's it. But for this, what you need to understand is, when the container is created, inside the container, this script should be available. So that is where you need to make sure that the image has the script. So when you run, it will just go inside the container, pick up this command, and it will execute it. So that's what it's all about, what command that you're going to run. Instead of that, you can run any kind of script that you want, which could be a shell script or a Python script. It's up to us.
So Adam, there is no way we can push a script that has on the host machine into the container and then run it?
I'll tell you. So now what happens is, like I was telling, so you can pass an environment variable, but if you understand again, the basic over here is, we are running the container as root. So that is where the process is getting created as root. In fact, the container process itself is getting created as root. So that is where, just like a machine, when you create a container, it's always running everything from the root directory. So now if you see, as soon as you create a container and go inside, whatever that you are running is based on the default directory. But if you have a requirement where you want to change the folder and then execute, then what you're going to do is, you're going to use another option called -w, which stands for working directory. Okay, so here you can typically tell what is the path in which you want to run. So when you are trying to run in a detached mode, all these things will be used, so that instead of using the default location, you can tell a different folder from which you want to run it. Okay, now let's take the same example here. Now by default you can see it's going under root, right? So now if I say -w and a different folder, then what happens? You can watch every default whatever that we have used is the same, there's no change, but additionally instead of going into the default directory, it's going to the specific directory what you have told. So this way you can choose what folder that whatever the command that you are giving or the shell script or the application that you are giving, from where it should be running. Okay, okay, so
Adam, what is the benefit to detached mode?
can you repeat it?
What is the benefit of detached mode?
What is the benefit of double?
Adam, please, can you ask others to mute Adam, please?
I know. Just a minute,
Hey,
guys.
hi
I
guys,
think
please who are not talking, please can you mute yourself?
Ilon, can you type the
Hi, Adam.
question? Yes.
I'm just
Madam,
telling what is the meaningful of the detached mode.
just exit them, so they should need to understand.
Okay, guys, give me a minute. Ilon, can you please go on mute? Okay. If I understand your question, what you are asking is what is the need of detached mode? I think it's the same question, but let me just try to answer you at the end. Okay, I'll answer you at the end once again, because we repeated the same. It shouldn't be a repetition. I'll answer it in some time. Now, coming back, you can see that if you want to switch a directory, you can typically use the -w and you can choose which directory that you want to go in. So that is how, when you are trying to start application, like someone was asking, now if I am running this command, where will this run this command? It will go by default to the home directory or the root directory and it will run. But what if the script is available in a different location? Let's say the script is available under a bin folder. Then you have to say -w and then bin. This is one option. So when you say, what will happen? Whatever the command you are running, it will create the container, go inside this folder and then run. So that is how you have to think how to run different things. So this way the container will get created and Docker will set this folder as the working folder. So all the commands that you're going to run inside the container will be based on this. Okay, so this is one option. And now coming to the other question that we have is the same way. Now when you're creating a container, whether it is an interactive way or detached mode, you will be inside it and it is isolated. But any point of time, if you want, how do you try to put some file inside a container? Now let's say the same example, that I want to copy some file from my host machine to my container, or vice versa, from my container to host machine. So at any point of time, if you have such a kind of requirement, then you are going to use an option called Docker CP. Okay, so what will this CP do? Now Docker CP will try to help you to copy the file, whatever that you're giving, that is one file at a time, from your host machine. Okay, so now this way here, so this is the file name on my host machine, so I'll say that as host file, and then followed by, if you want to copy to a container, then it goes back to your what is the container ID or the name, and in that, what is the path that you want to copy. Okay, so this way it will try to copy the file from your host machine to the container specific path. The same way, suppose if you want to copy the reverse, then all you're going to do is this, where you first choose the container and the file where you want to copy, and then put to a particular path in your host machine. So both the things will happen. So that's where you will be able to copy. So just to quickly show you that. Now, let's say that I have a file. Okay, I'm running this. So what I can do is, let me just create a file quickly. And I'll redirect it to a file called dummy. So I have a file created called dummy. So what we will do now, we'll try to copy this inside the container. So I'll say docker cp dummy, and the name of the container is test01, and I just want to copy this to 10 folder. Okay, so now if I want to go inside and see, this is where I can say docker exe and test01, and I'll say ls temp, wherein I don't want to go inside the container, just display. So you can see this file has got copied. And again, if you want to see the content of the file, then again, either I can use exe-it, if not, I can just use the exe in this way. Okay, so these are the ways. Now, if you can see how typically you will be able to use a container. Okay, so going back again, it all since from the basics. So this is where I was trying to explain you from the beginning on how do we create a container, whether it's an attached mode or detached mode. And then for that, the mandatory options are, you need to give the name of the image, what mode you're trying to create, and then you're going to typically tell what will be the first command that you want to run. If not, what will be the default command that will be picked up from the image. And then you're going to choose a name, which is an option for you to identify. And further, as per your need, there are many options that you can either specify a folder from which you want to start your first command's execution, or is there any environment variable that you want to pass. And as you move on, you can stop a container or start a container again at any need. And again, at any point of time, you can also go back inside a container. But remember, as long as the container is available, all the contents inside it will be there, so that when you start it again, you will be able to get it back. But if you delete a container, along with the container, all the contents that you have inside it will also be deleted. Okay, so this is what typically we call it as container management. Okay, now along with this, we have a few more options that we need to see. That is, how do you completely share a content from a container or multiple folders that I want to share between host machine and my container. That's what we call it as Docker volumes. And at the same time, now we are just talking about running application. Now, what if I want to access the application? So how are you going to access the application, especially a web application? Then there's another concept, what we have is called as port mapping. Okay, so these are the things that we will be seeing it in the next session. But for now, I'd like to stop the session, and I would request everyone to go back, give us a like and share this. And once again, thanks for joining the session.
Adam, I have one question.
Thanks.
Yeah, just a minute. So